is the more regional scale model, and
All right. We're
has great points that are closer to geographic locations. Other things you can use like
we're live. Okay. Yes, I guess I realized that one of my only roles in a community of scholars is late at night to look at radar images and wonder what is that, and then ask your opinion. I don't know. Did you notice this on Friday? This is Saturday, actually. Saturday evening, around 6 p.m. And the loop that I made after the fact is sort of hard to do, but I'll show that in a minute. The odd thing is that this isn't a cold front precipitation pattern. It's suspended hydrometeors that are reflecting the radar, and it's in this nice annular shape, kind of uniform width. I've never seen anything like it. And the individual precipitation that's falling occurs in streaks that are slightly inclined inward. You see this little angle here, all the way along here. And I'm wondering, is that cross isothermic flow? What is this angle? Or is it some kind of a, when in the Cycles project, in studying landfalling storms in the Pacific in the 70s, they found that along the front you'd have a kind of a secondary instability, and the rain cells were sort of slightly inclined with respect to the front. But I don't know. Do you have any ideas about what that could be?
No, I saw the same thing that night, and I was just thrilled to see it because it was so interesting.
Yeah, it seems like an opportunity for somebody who really has their fingertips on data at mid and lower levels in the troposphere, not the surface, not the uppermost troposphere. There's something going on here which is a little bit unusual, I think. So I guess this was earlier. We had this cutoff low situation. You can sort of see a streak of precipitation associated with that. Some of it was reaching the ground. This is the shot of upper level water vapor about the same time. Here's lower level water vapor, and then waiting a day, the sun came up on Sunday, and this thing was still hanging around, this big disk of cold air, which I realized to explain this pattern of clouds, this big disk, there's a slight uniform uprising there, and it's not just buoyancy, it probably has something to do with dynamics, doesn't it?
Yeah, so we had talked about this on Friday on the forecast for the weekend. I had this impression just broadly, and I just sort of put it out there, kind of cloudy, kind of miserable most of Saturday and Sunday. And if you don't really think too much, or if you were out late on Friday night and didn't think about, because we were celebrating homecoming and all that, and you got up late, you might have said, oh, we're going to have a decent forecast. But I remember when I woke up on Saturday morning, bright, sunny skies, clear skies, and I realized the one thing I had neglected to sort of think about in the forecast was the dry slot associated with this intensifying cyclone that was to our north. So once that dry slot went by, we were under this large-scale cyclonic circulation, and we talked about perhaps Ekman pumping being one of the sources for this broad. You just described it as, I think actually described it maybe very uniform, slow upward motion that was just, if it was just moist enough, you could get some cloudiness and get maybe some precipitation. But I'm wondering on the edge of this big rotating disk of air where you have a convergence, could there have been enhanced convergence just on the edge of it? I think in the surface maps that you showed, that could have been forcing some ascent. There's probably a temperature gradient with that cloud cover versus no cloud cover. So in satellite imaging, so on the edges of that, maybe you did have sort of a frontal-like structure that was producing precipitation. That's an idea.
Sort of a mid-level frontish set arc.
Oh, was mid or even surface? Could you go back to the surface map that you had?
Well, I'll go right back to this. This just vividly shows that it lasts a long time, and these individual elements of streaks spiral continuously inward at a slight angle all along there. And it's just, I've never seen anything like that. Okay, so that's the main thing.
This is a very typical boundary coming out of the south side of it too, from southern Iowa.
And the edge of it, part of it's perhaps it's just so super dry in the middle, and perhaps the upper mid-troposphere the water vapor can show it's really dry there.
So here's the surface for 6 p.m. that Saturday. I guess there's a sort of hazy little rain, little snow kind of in like that. But this band was down in here.
Right. There's a little bit of further in the cell.
I guess like that. Maybe might coincide with it.
I wouldn't be surprised if there's some sort of really small scale thermal field in the middle and upper troposphere that's contributing to what happened there too.
It just struck me that somebody who's really good at synoptics would maybe figure out this problem.
Not at a glance, because it's a weird thing. You don't see it very often. I don't think I'd ever seen it either.
This one out though, so this one shows another feature that's related. There's something like just I think, the dry tones, but I haven't sorted out where the PV filaments lie relative to the dry tones, but there are these interesting waves that are forming along the boundary of, say, the north boundary of Missouri. So look at those waves.
Already
so those waves.
Yeah.
Yeah.
Isn't that amazing?
It's
Wow.
beautiful.
And that was actually forecast in the NAM.
And then
That's
just,
right, you did mention.
I don't know the difference between these two channels. They're both centered at 8 kilometers. Like, one's called water vapor, one's emission brightness temperature. I don't know.
What's the waves on that? Oh my gosh.
Yeah, they see this a lot in the Gulf of Alaska, these
Yeah,
really
it's-
wound up
that's
storms. It
interesting.
isn't so common here. This is very, very interesting.
So look at these
aspect of
guys. Okay, so, whoa. I thought, is this a barotropic instability? You always hear about that. Is this actually an example of it? So we tried to make cross sections of PV, but they weren't working out. But this will suffice. This will be the last thing I'll show. So 500. This is the forecast, but you can just see this PV streamer. Oh, stop it.
Yeah.
Oops. Kind of touchy. Well, so there's a PV streamer, like a positive PV streamer, and this is absolute vorticity, okay? Absolute vorticity, and there's a maximum. Therefore, the gradient of PV is positive here, negative here. This switching of the sign is supposed to be just a general criterion for the possibility that a wavy perturbation, a little sinusoidal perturbation could grow based on differences in kinetic energy at the basic state.
Mhm.
So it's similar to the wake behind a cylinder. You have von Karman vortex streets developing as a secondary instability because there's a curvature of the flow that reverses sign. And so maybe PV streamers in general can lead to these kinds of waves and promote mixing. This goes way back to the mid-'80s in the stratosphere. People were trying to figure out from a knobbly glass view of Rossby breaking, maybe it was in blobs, but then at higher resolution, there were streamers that would develop into waves and break up into little rolls. So that was proposed as a secondary mechanism for destroying Rossby wave energy at large scale. Now, I don't know if this is barotropic instability or not, but that seems like it's closely related to the annulus of hydrometeors. It's just on the south side of it, and I don't understand either one of them. So just throwing those out for.
Seems like you understand it pretty well.
Well, the second one might be barotropic instability, but I don't know. There are papers on PV streamers, and you'd think that they would, develop that thing more if that were the case.
Matt, so why would you think it wouldn't be barotropic instability? What would be the factors that would discount it? I think you're right.
I guess, well, there's the caution of the theory for Rayleigh quote criterion is it's a necessary condition to have a reversal of the flow curvature, or beta minus CYY reverses sign, or PDY reverses sign, but it's not sufficient. And so that condition exists without waves forming pretty often. So what's the difference with when a wave will form versus
You
not?
just need the perturbation, right? Once something's introduced into the flow in such an environment, it will grow. Maybe there's flow across the Black Hills or something. I mean, that's on the western side of this disk.
Just to trip it, to
Yeah,
have
just
an excitation
kicks up
of it.
some little perturbation, and that's enough in this environment to roll up some waves. I wonder if that isn't part of the story.
And you probably want to be under favorable deformation, so you're not stretching out any potentially developing vortices. So maybe if you calculate the total deformation of the flow, maybe it's weak enough so that it's not ruining a potentially growing vortex.
But not so weak that they all spin up to their own
Yeah.
monstrosity either. They get some strength.
Yeah, but as that strip, as you were animating the strip, you could see it beginning to buckle. in
Yeah,
places.
yeah, it's really interesting. And
Okay,
it seems like it had some manifestation in precipitation areas this time.
somehow.
Sometimes you see it in the water vapor, like on these Pacific Coast events, and it doesn't seem to have any signature at all anywhere else. But this one surely seemed like it did. So,
In general, it seems that there's room to try on fire and wind bursts. Yeah. You see, I think you related roofing the one that got a big curtain master. Okay, so I'm going to get out of the way for some people who are eloquent with describing synoptics. Take over. Thanks for.
I'm glad you saved all that stuff, Matt, because I saw that on Saturday and I knew it was going to disappear because I don't have the capability to do anything to save it, including the stuff in the satellite. So it's really fantastic. I'm getting used to this stuff. Yeah, thank you, Matt. That was really neat. And I think one of several really interesting events that have occurred this month of October and some that still stand to occur in the forecast. It's just been a great month so far. And I think it's going to remain so as we go forward. So let's start with our satellite movie over the continental U.S., if we could.
We look today.
Yeah, just today, because we got to make this. Michael's got to get out in a bit by about 1:10. Okay, so a lot of news about the bomb cyclone. I've heard this in the news even here about this thing. And it was devastating. There were 70, 80 mile per hour wind gusts along much of southern New England's coast. Trees uprooted, branches falling all over the place. This is not the most uncommon thing for that part of the world, though. I remember when I was a boy, we had a storm like that probably every other or every third October. So they're not completely unprecedented, and they're certainly interesting when they occur. But this was a really good one and developed extremely rapidly right along the coast, and we can say a few things about that maybe by looking at some of the charts as they stand today. And then we've got 16 just sitting out here in the middle of the Gulf of Mexico. I think Michael's going to say more about that. I'll just point out the fact that it's an impressive-looking convective disturbance today as compared to yesterday. And much of the western coast and the Panhandle, south Panhandle coast of Florida is under the gun for the arrival of 16. So maybe it'll actually get a name, but it's got strong wind gusts already. It's one of the weirdest things. It's an unnamed beast of a disturbance.
Right,
So,
60-mile-an-hour wind.
it's just weird. So anyway, when you get so sensitive that you got to have certain characteristics before you can join the club, that's the problem you have with these things. This one, you don't have to give this a name. You know what it is when you look at it. You know that's something to worry
Weather
about.
Channel
Same
gives
here.
it a name.
Yeah, Weather Channel.
They feel they need to.
That's artificial commerciality. I'm not in favor of that. So, okay, so that's the eastern half of the United States. We've had a couple of really nice days, beautiful couple of sunsets the last days in a row. But we'll see when we look at the upper level charts. Big ridge sitting over us, and actually now the axis of it perhaps moving slightly to our east, which puts us under the gun probably for some warm advection clouds coming in. And you can see there's a patch of high clouds that's moving across the area today. There was almost none of that even last night. But you can even see the ridginess in the flow just by the satellite picture. And then we get an oblique view of what's going on off the west coast. And it's hard really to make any sense of it because mostly what's there is a zonal jet coming roaring into the Pacific Northwest. And finally, it's taken a few days. It's been 3 days straight of a zonal jet in the Pacific at high latitude, probably a function of the tropical cyclone that hit Japan, at least related partly. It's going to finally break up into waves. And the first one of those will make its way into the central U.S. and give us a pretty interesting Monday and Tuesday, I think. So that'll be fun to look at. I want to show you a couple of things about it on Biz5D, but not many, because we don't have our normal time today. Okay, can we take a look, Pete, at the radar, national radar loop?
Are you going to that high clouds? There's a really vivid sundog to your.
Oh, is that right outside now?
Not right now, but I was
Oh.
biking in this morning. and
Oh, is that
I was
right? I didn't
over
notice
at
that.
Lake Nona.
Yeah, oh, cool, that's neat.
You can send the rooftop camera.
A lot of cirrus
Not
is
a check.
necessary for that, yeah.
I took a picture.
So radar, finally, it's not raining any longer anywhere in New England. It doesn't appear. It's probably still breezy, but they had a really bad couple of days. I guess there's hundreds of thousands of people still without power, and there was a disruption to travel. The Astros are now a game away from the World Series. They are dispatching the Yankees with ease, even with interruptions by rain and storms. And then here's the northern edge of 16 as the precipitation comes on shore. The Panhandle of Florida. It's really going to be a Florida storm, the whole west coast and the southern Panhandle. and then a little bit of Louisiana and Mobile Bay are under the gun. And the central United States, beautiful day today. Some high clouds and light precipitation in the western Dakotas and some of the other parts of the high plains. Here you can see scattered open cellular convection. We'll take a look at the West Coast satellite image in a minute. I think what we're going to see is the jet axis is about here in the cold air that's been just poleward of it all week long out over the Gulf of Alaska is now able to manifest itself on the shore with spotty convective showers. These are usually fairly shallow. They're 10,000 foot tops, 15,000 foot tops often, and they'll have sometimes pea-sized hail, depending on what the temperature is at 500 millibars. That looks like about minus 28 or so to me by the spacing of those cells coming into Puget Sound and western coast of Washington. So we'll see if that's right when we look at the 500 millibar map. Okay, so let's go to some of the super peats. Pete, it's a real pleasure to say go to the super peats, Pete.
Could you repeat that?
Yeah. Let's start at 500 millibars if we could. First off, the coast of Washington State, minus 26 at Quilly, so right in the right range, minus 28 further up at Nanaimo. So it is like in minus 26 to minus 28 range, not quite minus 30 where you get bigger spacing between the cells. And maybe more chance of hail. I don't know if there's any hail falling out of those, even along the coast of Washington State. But here's the big ridge in the central United States. And you can, if we looked at a series of these maps from this week, you'd have seen this thing march slowly across and amplify a little bit. And right about this morning at 7 a.m., it's just about at our longitude. So that puts us at the end of the guaranteed upper convergence. In fact, now we're probably going to start to see upper level divergence coming in from the west side of the upper ridge axis. Down here, we've got a trough over Nevada and New Mexico, Arizona and Utah. And so there's subgeostrophic flow at the base of the trough, supergeostrophic flow at the ridge of the crest of the ridge. And so right in between in the central plains, centered perhaps over Nebraska this morning at 7 a.m., there's the maximum upper ageostrophic divergence. And so one might expect to see some development going on in the central plains just to our south.
Point out that there's that trough in the Gulf. It's almost a little like a Rex block in that ridge.
Yeah.
And I think that trough is actually that whatever you called it, the tropical
16.
Yeah, not quite. It looks like it's a separate entity from that.
Oh, yeah, right.
Okay.
Wow,
But they're interacting.
But they're interacting, yeah.
that's interesting.
John, a question about the position. Like if you were over Nebraska, over say Lincoln, right?
Yeah,
that's a nice
your
little-
hometown.
Yeah. If you were over Lincoln and a little bit further to the west, but anyway, if you're there, would you really expect to see significant divergence? Because the flow is pretty straight for a long stretch. I mean, between the trough and the ridge.
Yeah. I'd say it would be weak. You're right, because here's where it's supergeostrophic, here's where it's subgeostrophic. But the divergence, however the magnitude is, going to be maximized here, is my guess. But it's not going to be substantial. I like to see these things closer together.
So shorter wavelength.
Yeah, then you can get explosive. Well, like here, here's a big trough axis and here's a ridge axis.
Right.
And this is in the late stages of this disturbance. But while it was mature, you can see the distance between those two is considerably smaller. So one concentrates the upper divergence and makes it more intense. The shorter the wavelength. Yes, this is a broad, very large amplitude wave disturbance.
I think that ridge actually has tropical characteristics, particularly aloft, and I think it's interfering with the quasi-geostrophic dynamics and probably.
This ridge?
Yeah, that ridge there. So I think to the west, you could see the waviness of it going over the mountains, how prolific the gravity waves are embedded in it. I think that's a sign that the quasi-geostrophic dynamics is less dominant than it might normally be.
Yeah, maybe that's right. What we'll see emerging out of in the Vis5b, we go all the way out to the end of the evolution chain here on this map. We don't go quite that far on the domain. I'll show you in a minute, but you can see a little bit of a wave right there in the geopotential height line, and consequently a couple of regions of different temperature advection. Finally, along what's otherwise been a zonal jet all week long. This will be a wave that emerges out of the front end of this jet. So can we look at 300 millibars, Pete?
John, do you think that was a way from higher latitudes that's interacting with us to begin to upset it? Because you said initially it was for a long period of time, it was pretty straight.
I don't know. I mean, the jet itself, the longer it is and the longer it tries to stay zonal, the less likely it's going to do in the mid-latitudes. It's very clinically unstable. So if we had a map that went a little further back to the north and west, we could actually maybe trace that, but we can't. It'll go out of the domain. There is a little bit of a cutoff in the geopotential height field, and so look at this 180-degree wind shift right over the Aleutian. So there's an upper trough there. I don't know where it came from. It may have developed spontaneously along the jet. It may have invaded from higher latitude. I don't have enough information on this map to make even a guess about that, but it's a good question. And you can see once one of them gets instigated, then there's going to be a ridge upstream of that, and there's a downstream, there's an upstream trough from there, and so the whole jet starts to break into waves, and that's where it gets really interesting. These are very broad scale waves, as Greg was pointing out there, and Michael too. They're very high amplitude but broad scale. So K squared plus L squared is fairly large here on these waves. And this one here is considerably smaller, and we'll see what happens to that. Notice just a hint of a thermal ridge at 300 millibars right at the crest of this, or the trough of this wave. So there's cold advection behind, warm ahead, even at 300 millibars, and that helps to amplify the wavy nature of this disturbance. Probably mostly at levels below 300 millibars. Can we go to 200 feet before we're done with these? And see what we see up there. So at 200 millibars, the jet speed is just a little bit weaker than its maximum further to the north and west, but this is just a deep, nearly continuous 110 knot wind speed maximum right off the British Columbia coast from 300 millibars well up to 200, probably a little bit below that 300 millibar level as well. And then you can see the broad wave features over in North America and adjacent water. So it's a pretty wavy flow for us currently. And even a little bit of the troughiness that Greg mentioned at 500 millibars, you see at 200 as well. So it's interesting. And who knows, maybe some of this flow is outflow from, sure it looks like it's curved right in there over Mississippi and Alabama from 16. So there's some interesting interactions going on. It's a great time of year for that. You know, the extratropics get revved up at the same time the tropics are still sending disturbances forward. And you can really have some nice interactions as a result. So what I think I want to do is I want to talk about, let's go to the West Coast satellite image first, Pete, if we could. And see what's going on there. So here we are, thank you. Here's the West Coast.
That seems to be stuck.
That's February.
Stuff.
Yeah, that's.
Oh, February, yeah, that's, look, it's snowing.
Let's go.
Yeah, look at all the open cellular convection in the whole Gulf of Alaska. Little disturbances spinning up. The jet, remember, is like oriented this way. So it's the boundary between open cellular convection in the cold air where the stratification's weak and nothing quite like that happening south of it. And so one of these, once in a while, these patches of convection can get themselves a little bit organized. There's one here just on the panhandle of Alaska that did so yesterday, and now it's kind of dying away. Here's a second one that you can see emerge as better and better organized, and that's the one that's actually making its way onto the Washington coast. I doubt that it has any organized circulation, but the more convective elements that pop up, the more likely it is to start to have its own circulation. Yesterday afternoon, there was one, it might have been this, that didn't quite put itself together, but it looked like it was going to. A little patch, an unusually concentrated patch of convection over the central Gulf of Alaska that didn't quite have a circulation yesterday afternoon and apparently never really got one. But nonetheless, they do aggregate somehow, and they're quite separate mini organizational units. And they're all streaming eastward, carried along by the jet on the cyclonic shear side of it. So that's very interesting in these kinds of regimes. When you live in Seattle, Matt can testify to this, you can have periods like this where it'll just rain for, you know, on and off all day long. There'll be a little bit of a break, but the clouds won't go away, and then it'll rain again. The same is true up in Bellingham, I'm sure. And so it's a stormy, but never scary stormy time of the year sometimes. And this looks like a good example of that. Okay, I want to trace into the forecast only one element, and I'll do it with Vis5D, which I had on the screen there somewhere, Pete. I don't know where it is, but in the terminal window. And just show you one thing about it. Now, we won't have enough time to do everything about it, but it's kind of interesting what I saw. Yeah, so here is approximately 500 millibar isobars. So these are at 5.4 kilometers at every 4 millibars. And then underneath it is isotherms. It's from the 12Z GFS run from yesterday, and I did that on purpose to kind of watch this thing come into the domain. So if we can step ahead, this is the flow that's kind of off the Pacific Northwest coast, and we'll see a little concentrated disturbance come in a little bit of a ways into this. It's coming here. It's this next one. And right about there, you can stop. Notice how the isotherms have there a little bit of structure to them. A strong gradient in this location, and then a couple of the colder of the isotropes will actually have a little bit of a geometry to them. That's the development of a pretty decent upper wave. And this gets us to this morning at, well, Friday 12/21. This is this afternoon. Yes, this afternoon. So this is the feature that we saw a little bit further upstream in the 12Z map starting to take shape. So let's go just a couple of clicks ahead from here. And this is the GFS forecast. I think this might be the time that I drew my cross section. Let's put the cross section of theta first on the map and see if it's in the right spot. No, I guess I'm waiting for it. But here's the baroclinic zone that's starting to develop in association with an emerging shortwave in an otherwise broad westerly flow. So let's watch this thing go a couple more times at 500 millibars. Pretty decent temperature contrast. This is about the time probably I looked at it. Warm advection here in cyclonic shear, and that isn't really good for an upper front. But down in here, it's trying to get itself rearranged. And if we tilt this up, we can see what the structure through this along the Oregon coast is of this upper baroclinic zone. So it's pretty nice looking upper baroclinic zone. It does not show a surface front, but it's all in the middle and upper troposphere. And if we put the wind speed on top of that, oh, I never changed the contour. Let's do 10 parentheses 20 to 50 or something, so we're not looking at everything. 20 to 100, I guess, would be good. Then we know if there's something bigger than 50, it's in there. I think it's on, let's see if it's on the same line. We have to go to the top. I think I arranged it so it was. No, I didn't, so we got to slide this side over to up there. Sorry about that. I had it all set up. Okay, so there's our wind speed maxima. And remember, it's 20, 30, 40, 50, 60, 70 meter per second jet, and it's well above the tropopause, or it's up on the tropopause boundary. It's almost in the subtropical jet range. Look at this extraordinary horizontal shear. And then if we show the PV, which I think I did set up, yeah, that's the right PV. And one gets this little nose of high potential vorticity from stratospheric type air coming right along this upper baroclinic zone. And we're
Trying to change the color to something that's a little easier to see.
You go to red.
Well, this works. You can just take theta off for now. But one can see that the PV is right there in the strong shear region, and it's down along sloping isotropes as well. And then one last thing is the vertical motion on this cross section. And there's subsidence just about through the jet core. It's displaced a little bit to the cyclonic shear side of the jet. And that's helping to usher some of this PV downward at this time. So this is all negative vertical motions. I only contoured the subsidence. So everything's kind of working in favor of dragging some of this high PV air down these sloping isotropes deeper and deeper into the troposphere. And that we're going to see when we go back to the top. We'll see all of those things working to produce. Let's take the pressure off, I guess, and then put the vorticity on. So you can see this little strip. Maybe I can take theta off. I guess that might be better. You can see this little strip of vorticity that's kind of right along that upper front. And then click forward a couple of times, Pete. And it starts to ball up over northeastern Colorado, western Nebraska. And if we put the theta back on, you can kind of see what the structure is looking like now. It's a little bit of thermal, thermal wave that's obvious even at 500 millibars, approximate 500 millibars in the thermal field. And then if we take a look at the PV, not that, I'm sorry, the surface, which I've got colored already. Let's go back and watch this animate. So here comes our wave right there, that little wave in the jet. It's a steep tropopause boundary. We saw that in the strip of the vorticity. Here it comes down into the central plains. You'll see it fall up here over Nebraska and Colorado. Then it weakens a little bit. Watch, see the color is giving you an indication by pressure that it's going back up. It's receding to higher elevations, but something comes in at the base to re-energize this thing. And it's a region of cold advection and cyclonic shear, especially right here over southern Illinois and Indiana. And if we put the sea level pressure on top, I think I have it at the top map, yeah. Everything 1,004 millibars and lower, if we go back to the beginning and watch that animate, you can kind of see what's going on there. There's the old storm. So here comes our disturbance. It's coming right there. Little bit of a drop in the pressure there. You can see here's this little mini pressure wave. And then when this upper wave gets a little bit better organized, it takes off in western Nebraska. And you'd think it's going to die. It doesn't quite have any oomph left anymore as it sits over Lincoln and Omaha. But then a resurgence of development aloft puts itself in the right position for subsequent surface development. So this thing's going to hang around through Monday and Tuesday here. It's going to be windy, probably rainy, and then turning colder. And this becomes a dominant feature in the circulation for the coming week. It's just going to sit over the western Great Lakes states, both at the surface and at upper levels, as we wait for the next disturbance to move in afterwards. So
I think
it's a
that-
pretty nice evolution.
That development is being leveraged by the outflow of that tropical, semi-tropical cyclone in the Gulf.
16?
Yeah,
maybe so.
There's a tropical plume coming up, and I think when it resurges and amplifies, that's when that tropical plume's.
Because here's a time where the upper wave, in terms of how deep the PV, 2 PVU has made its way down, it's receding back. It's this thing here that probably has some interaction.
I think
with
they
that.
interact. That's right.
Yeah, because look at how this is going to get a little bit more orange, right, as we go forward in time. This thing definitely gets more energetic.
Right. But by that time, this is Monday now, right? Monday evening.
Yeah.
That the remnants of 16 or what will become Nestor is going to be already off the East Coast.
Oh, they're in the wrong place.
Was that right?
Yeah.
I don't know that.
So I don't think that's the timing there, but
Okay.
it's interesting where that second
Yeah, what's going on here?
form.
I know
Interesting dynamical question.
the GFS products are showing a lot of tropical plume coming up at higher levels. I was assuming that was from 16, but I don't know, it could be coming from something else.
Yeah, I guess I don't know either. I don't.
But if we could go back one more loop through, a couple of things to point out were the trough that, Greg, so if we stop at this morning, see that little feature going across the
This
northern
right
Gulf
here.
of Mexico?
Yeah.
Sorry, so that's what's interacting with 16, maybe Nestor shortly. And then you can follow that along. You'll see a little, there's
There's the
Nestor
minimum.
Yeah, there we go.
down there that it makes landfall. I think by that time,
And it's gone from the 1,004 universe anyway, after that. And that's where there it is again. But here's our wave, and you can see this just little bulge in the pressure that gets itself better organized as this thing balls up. But then look at how intense that is. And then going forward, it's receding. And then this one is coming back down in the northwesterly flow and rebuilding the upper vortex structure. And down sheer of it is where the development goes on. You start to see isobars sprouting out of the ground over
Let's
the.
see how that blue is pushing way up there.
Yeah, right here, right? This.
Well, yeah, you can see it pushing
Yeah.
up there, and then there's
Yeah,
another push further north.
Yeah, but this one's probably 16.
Yeah, that's probably the one that's most important, but
And then at this time, you have a pretty decent dual jet and strong tropopause fold right in that location. But that's a perfect spot for high PV because there's this elongated baroclinic zone that points poleward towards the cyclone center. And so there's really nice PVA by the thermal wind driving the development.
what I've noticed is that low PV plume in this one, unlike the previous one, actually winds up going almost all the way to the pole. It shoots up that ridge almost
Yes,
all
we
that
looked
way.
at this in the long term. And in fact, Tuesday and Wednesday, we get quite cold here. We'll see snow
Yeah.
again maybe on Tuesday. And on the other side of the cyclone, you have air that's +5 at 850 all the way into Greenland.
Right,
Yeah,
right.
it's very dramatic. Southern Labrador Sea gets very warm. Yeah, that's right. It's all tied to this development. It's very true. It's really interesting. So we could spend all day, as we always can, with the DIS 5D. It's such an interesting way to look at things, but there's a lot of interesting stuff coming up. And this isn't the end because it looks like in the medium to longer range, October stays cold in North America, and it also stays energetic. So there's going to be one storm after another traveling along a baroclinic zone that extends quite far south for this time of year across the central U.S. through late next week. So right into Halloween, it's going to be chilly here. Really interesting. So that's what I have, Michael.
okay, thanks, John. So we're gonna get started. I guess on watching right now online is actually Chris Malcolm from
Nestor.
oh, now it's been named.
Yeah.
Nestor was what? He was the king of Kilos. and he helped the Greeks during the siege of Troy as an advisor. So
Oh, yeah.
I don't know, maybe this is he's also tropical storm in the Atlantic, but kind of Chris Smolcom and the other folks that are online watching today. So this is the latest. This was, if we refresh this, maybe it's already been updated. From Tropical Cyclone 16 to still Tropical Cyclone 16.
It's a 10 o'clock advisory.
But yeah, so the 10 a.m. advisory, you can see the location of the storm. You can see this cone of uncertainty, which is just based on climatological forecast errors, the width of the cone. And you can see it makes landfall as a strong tropical storm. It had winds of 60 miles per hour at the 10 a.m. advisory, and presumably they're forecasting to intensify. Maybe now that it's got better organized, you can look at the satellite imagery that John was showing earlier. You can see that nice big ball of circular convection that's formed over the so-called, maybe the emergence of a central dense overcast over this. Maybe this is going to become maybe even a weak hurricane before it makes landfall, depending on the conditions. The issues with it was under a little bit of shear. One of the interesting things is the structure of this storm. If we go next to this phase space diagram that we looked at last week for, I think it was Melissa, C shows the current, and maybe we can even try to refresh this to see if we'll get the 12Z or even replace that 06 with a 12. Here, I don't know if it'll work or not. It's based on the GFS analyses, it may not be ready yet. There it is. You'll notice it was earlier, the C was centered on sort of this indeterminate region on this phase space. And this is basically used to characterize the disturbance. If it's a nice symmetric warm core disturbance, that's a tropical cyclone. If it's cold core, it might be one of like the cyclone over the Lever Sea right now, the remnants from last weekend's storm, that would be considered a very cold core cyclone, and you have anything in between. So based on the 12Z analysis, they've actually moved it from this sort of indeterminate region more toward a symmetric warm core, which is what a tropical cyclone is going to be characterized by. So what does this mean? For those of you taking 310, you'll begin talking about thermal wind balance probably later on this semester. But those at 452, know this well. If it's a warm core disturbance, we're referring to if you did a cross section toward the center of it would be much warmer than its surroundings. And so what thermal wind balance and geostrophic balance would apply, or hydrostatic and geostrophic wind balance would apply, would basically mean this is thermal wind would suggest that you have the strongest winds at the surface of this disturbance decays as you go upward with height, and eventually sometimes even becoming anicyclonic in the upper troposphere. So strong lower tropospheric cyclonic disturbance, and you can see the track of this storm. Somehow the map has been lost. If you scroll down, I don't know if the map shows up better on this. If they haven't updated the map yet. But the track of this is supposed to take this disturbance. Right, that was number 34. Let's go back.
Well, here comes track and SST on the bottom. No,
This is looking weird. Let's go back to their page. One more click back. Make sure we're looking. And then refresh this, please. Make sure we actually are looking at the right thing. The numbers change, so that's why. The 34 is down here. Let's go to 29. They changed it. So they actually do keep it still in this indeterminate. It was kind of odd that we shifted. But they have to become an asymmetric warm core disturbance. This is the track, and the color here matches with the color here, as you can see. But they take it across the Gulf of Mexico, across the southeastern United States, moving offshore. You'll see in the forecast over the weekend, and then becoming a cold core, or basically a symmetric cold core disturbance by the latter part of this weekend. And we'll do a few cross sections using tropical tidbits tools to sort of interrogate the structure of this cyclone. So the C indicates the current location at 12Z. Here's the track, and you can see the over time it becomes more asymmetric warm core disturbance. So according to this analysis from the folks at FSU, this would be a hybrid disturbance. Looks like the Hurricane Center is now labeled as a all-out tropical storm nester. So let's go next to tropical tidbits. And let's go to the forecast models, and we'll go to the GFS. And let's go ahead a couple clicks. You can sort of see the trajectory of this. This is moving toward the, we'll go back just before landfall. It's down to 992. Let's just do a very quick cross section from west to east, not too long, from just south of New Orleans to, you're going to hold down the, that's going to give an average sounding over that box. think it's a control key and then slide across that. Okay, that's really right. And let's look at PD. It may want to go a little bit longer, but we'll see how this looks. So it's kind of an odd shape. But remember that you can see where the cross section is from the cyclone located sort of a third of the way along this cross section. This is variable potential vorticity that we're looking at ISO surfaces of that Professor Martin was showing. You can see, and again, you could do this in a number of different ways, but the potential vorticity disturbance is really located in the lower troposphere. These green lines, that's the shaded. The green lines right here are isotropes, potential temperature, and you can notice where they dip down, potential temperature increases in height in a stably stratified environment. So this dip down here indicates it's warm, shows the warm core nature of this, and you can see that that warm core nature kind of fades as you go further up. Look at the winds. These are the winds into the page are positive. Into the page are negative. Winds out of the page are positive, right? So these are positive. There's these solid lines right here. The winds into the page, really strong 40 knot winds into the page here. And notice you don't really see a symmetry in the structure. So this is warm core. It's not quite symmetric. That's kind of consistent with the space diagram. And this PV tower being tilted over might be an indication, at least within this cross section, that it's being still slightly sheared by that upper trough that was located over Louisiana. So it's still a pretty decent storm in the forecast. We can go back to the map.
It looks like the outflow of this is really shallow.
Yeah, it could even be
400, 500
well, right.
Yeah.
It could even be,
So it's not a real tropical storm.
right. And so also it's probably not gonna have as much of an imprint on future storms as
Right.
it was used to.
Yeah.
Polar low.
It's more like.
It's almost like a polar, it's very small height disturbance, 992. We can see heavy rain. So what are the impacts likely to be? You can actually go back to the Hurricane Center page for just a second and just check out impacts. This is where they have the warnings that are located. With the strong winds, it was at least 60-mile-per-hour winds earlier. We still have the winds at 60 miles per hour. And these strong onshore winds, and looking at the concavity of the coast, that's going to pile up a lot of water east of the track. And so we're looking at concerns about storm surge flooding. Also freshwater flooding from the fact that we're going to have this track across land and it's going to produce lots of rainfall. I don't know if they have the amounts in this particular advisory or not, but they're looking at flash flooding possible across the southeastern United States as it tracks across this region. We'll look at the forecast model amounts in just a moment. Actually, here's the rainfall potential right here. So obviously out of the Gulf, a lot of it, and then you're looking at over the course of this life cycle 2 to 4 inches of rain. And if I recall, I think lots of places in the southeastern United States over this late summer into early fall have been dry, so this is going to be perhaps helpful for them initially. Let's go back to the tropical tidbits page for just a moment and just watch the track of this as it moves across the southeastern United States. And another thing that I want to focus on, I'm going to first look at this, then we'll look at the rainfall for the weekend and try to diagnose what's going on there, which I think is a little bit odd. So you can see this disturbance emerges right off the East Coast by this weekend. Notice a lot of the accumulated precipitation is east of the center. This is becoming more, probably still sort of hybrid in structure. And in fact, if we were to do a cross section for this, let's just do that. Maybe from here, east northeast. We don't have to go too, I'm gonna keep it somewhat symmetric, but yeah, stop right there. Take a look at the PV. You see, we lose a lot of it. So this disturbance is probably more focused. You can see there are certainly winds, cyclonic disturbance, but you can see that the warm core structures, at least in this cross section, has faded. And I'm wondering if this is more driven by the thermal structure at the surface. One of the things that you learn about, if you're trying to look at the structure of this disturbance from a potential vorticity perspective, any atmospheric disturbance can be looked at as the sum of lots of pieces. One is the thermal structure of the surface, next the PV in the lower troposphere, and then the upper tropospheric PV. That's up in here. There's not much in the way of any significant upper PV undulations. It's kind of interesting that maybe the way we have the cross section oriented, but you can see here, strong low-level winds right here, and this is almost like what people term an edge wave. You have a thermal structure, isolated maximum potential temperature. That's going to have a cyclonic circulation. There's nothing else there to drive it. So this is kind of divorced from any of the main PV structures of the atmosphere, and it's just sort of spinning there out over the Atlantic. east of Norfolk. And so that's where the precipitation is. Let's go back a click, or get rid of this. So that's the track of this storm. Big impacts later on tonight, excuse me, through the weekend offshore. Let's go back to tonight's 0Z. And the next thing that I want to focus on is the weather for us over the weekend. This is kind of like the map, excuse me, that we were anticipating with the exception of the tropical cyclone, where this warm advection regime that we're going to see. And as we go forward, let's just see what happens with time. Light precipitation begins to break out. And if you look at this map really carefully, let's not go too far ahead. Let me go back one click. To my eye, it's not clearly obvious why we're getting this precipitation, at least based on the thickness pattern. There is a trough right here. There is warm advection, but I don't think it's necessarily too localized at this point. And it appears when we look at some other levels that it might be associated with sort of mid-level frontogenesis. I think might be the mechanism that's causing this region of precipitation to do a cross-section at some point. But again, you don't see any really strong or robust weather system here. Consistent with what John was talking about earlier, that's why I kind of probed a little bit about the changes in curvature in the flow. That ridge and the trough over the southwestern part of the United States. The curvature wasn't significant enough, but maybe that's just enough, broad vertical motion to help excite this, and there's just enough water vapor that as this air moves northward, it begins to.
Yeah, and there's low-level shearing frontogenesis there with a cold advection on the backside and a warm advection on the front side.
Right. So so this gradient doesn't look particularly distinct, but as Chris Martin is suggesting, with this trough right here, you have southerly flow on this side, northerly flow on this side, or northerly part of the flow. So that could be helping to intensify the thermal gradient. Let's change from this map, please, to the scroll, or maybe just switch altogether. Go to their lower dynamics. Take that as the temperatures in it. That's kind of Genesis as well. Might be interesting to see. Even here, you can see the frontogenesis is not particularly. That's the shaded pattern that's shown here. Is not. Sorry, it's the contours of the frontogenesis. Temperature advection is what's shaded on this map. Not particularly robust, but the precipitation is also relatively weak. So we might be just a threshold or two lower than what we need to be able to basically specify that. But clearly that trough that we saw at the surface shows up nicely here in terms of the wind shift. These northerly winds on this side and the southerly winds over us. I also look at pivotal, so I'm going to switch maps and just go back to our more traditional view. And we can step ahead slowly to see the emergence of the precipitation over the upper Midwest. Let's click on that. Going to Friday. Friday's going to be pretty decent. Let's go into tomorrow, and maybe we can go ahead a couple clicks to tomorrow morning. That's at 24 hours. Tomorrow is probably going to start off with some clouds. Anticipate the cloud precipitation to be well to our west. We'll go to tomorrow evening, 36 hours in the forecast.
Anyway, Ross, the 0 cents was in today.
Oh, thanks, Ross.
Where are we going, 36?
36 hours. And by that time, that trough just grazes by us, and we're now basically in sort of neutral temperature advection by this time period. And there's very little in the way of precipitation when it does go by. Let's go to Sunday morning. Let's go through this pretty quickly. By Sunday morning, front's gone by. We're sort of in this really weak light winds on Sunday morning. And the interesting thing is the disturbance that John was projecting, showing us in the BIS 5D that begins to develop. I believe this is the beginning of the spin-up of that disturbance out over South Dakota. 991. We can go to 992 is still just sort of emerging off of away from the Rockies, but you can see nice cyclone, strong winds, perhaps another snowstorm for the Dakotas as this thing begins to rev up. But we're still going to be, when we get to Sunday evening, still warm, so it's warm advection almost. So not a messy weekend for us. Let's go to 72 hours to Monday morning. So showers come in, and you can see this is a nice front that's going to show up, and that's really frontogenesis along the front as well as some instability helping to generate, I would guess, thunderstorms within that. If we were to go cross section through it, but this means the time to keep it short. Go to 96 hours, and watch the cyclone continue to deepen down now to 985. Strong northwesterly wind. Cold advection isn't that strong because the thickness gradient is relatively weak, but it's gonna feel chilly when we get to Tuesday morning. If you look at temperatures Tuesday morning, you can see they have fallen considerably. Let's go to the 2 meter temperature. Just in the 40s, and imagine if we go ahead to at 108 hours, that's gonna be Tuesday afternoon.
Chilly.
Even colder than it was in the morning, so temperatures falling during the day on Tuesday if this forecast is accurate. Let's go back to the precipitation type and rate.
Across the central plains, it's have no discernible warmth on it.
There it goes.
Clear, contrary.
This one especially doesn't, yeah.
Right. Okay, if we just keep advancing this, let's go to 144 hours. I'm gonna really just go through this quickly. You'll see that we get into this regime. I think this is actually sort of remnants of that storm. Cold, the baroclicity begins to shift well to our south. So this cold air comes in slowly. Maybe I should jump through all those maps, but you can see our thickness is now getting into the snowably cold territory, even for this time of year. 168 hours brings us to a week from this morning. Cyclone beginning to develop to our south, at least within this forecast. We're clearly cold, maybe even cold enough for snow this time of the year, and with the baroconicity to our south. But we'll see that this cyclone, as it develops in this forecast, tracks well to our south and east. So we actually scrape by in this forecast without much precipitation. But we'll come back and look at that. Let's go to 192 hours. See, this is just, we stay in the cold convection as a straight line. Let's just change models, right? You don't like one forecast, you can always look for another one. Let's look at the Canadian model. I select this not because I think anything interesting is going to happen. You see a much different forecast with that, maybe a little bit faster with the weather system. Let's go back to the GFS and just look at the run from last night. You see the track of this.
These are nationalistic. I mean, the US has a big storm in the US model, and Canadians have a big storm in Canada with this.
Not planned, it just happens that way.
Yeah.
But that's again also off to the well to our south. Let's come back to 12Z and then just complete looking at this run. Go to 10 days out, 240 hours. I like to do this, even though it's fantasy land, and a lot that we're missing.
Look at that.
Yeah. We don't stay super cold, or you'd probably stay seasonal, seasonally cold over this time period because the intrusions of cold air aren't that strong. Next weekend could be the chilliest period, but then the flow amplifies again. But yeah, snow in the northern part of the state is forecast by this model. Go to 288 hours. Now we turn cold. That's going to be a shift toward cold, and then we can just jump ahead to the end of this sequence. But we warm up again. So a lot of changes.
What about the trick or treaters?
Trick or treaters. Okay, so let's go to that date and we'll finish it up. Hold 300 hours.
Look at that.
So to go ahead. 324. Halloween forecast. And for those of you in dynamics, that's I always tried to time my lecture in the fall semester to talk about the Busanesca project.
Yeah.
Boo Senesca. Right?
Whether it's applicable or not is what I heard.
Good fun. Great. So so this is the Halloween, if you will, Halloween forecast for 0Z on the 1st, and it looks chilly, and temperatures probably in the 30s, I'd imagine, at this point. We don't set our clocks ahead until the 4th, I think.
But not windy, so it'll be comfortable for.
Yeah.
Yeah, in fact, we're already getting the return flow about to start up. And the temperatures at that time, if you go to 2 meter temperature peak.
Yeah, low freezing.
Yeah, maybe just about freezing or slightly below. If we move the cursor over there, we can get it.
Won't be in heat marks, but it's not gonna be warm.
No, so that's a different holiday.
Yeah, but you could still be in costume.
Right. Not me. Maybe you.
Put the cursor over the.
Anyway, so in short, the weekend looks like we might have a few showers tomorrow evening,
About 30.
and then pretty decent for the rest of the weekend until we get the showers with this deepening cyclone Sunday night into Monday. So we have most of the rainfall will probably be at night, not during the day. So not decent day, but getting windier Sunday night into Monday, and then getting colder. So that's it. Thanks, Matt, for a wonderful presentation. John, thank you all for coming, and folks listening online. Glad you could squeeze in that time to your forecast. That's an inside fund for people in Reno, Sparks, Nevada. Look at that one. Anyway, or it could be an ad for a breakfast place there. Anyway, have a wonderful weekend. Thanks, Pete. Talk to you later. All right.
I don't need to go back.
Thanks. You're welcome.
Okay, 10-minute break for the 141 class.